Okay, we're in Introduction to Statistical Learning, Chapter 9, and we're on question 2 of the conceptual questions. Okay, so we have 4 parts here, and I think that maybe I'll kind of go over all of them right away. So we've already seen an example of linear decision boundaries that maybe look something like this, right? Where we have an intercept, and then our 2 variables, therefore we're in 2 dimensions, but our 2 variables then are, they're being multiplied by some coefficient, these beta terms right here. And then each of these coefficient times variable terms are added together. They could be subtracted or whatever. But that's basically the rules for a linear expression. So now we're going to look at a nonlinear decision boundary that takes on this expression, and then so we're going to sketch that in part A, and then in part B we're going to try to determine the set of points that are on either side of that decision boundary. Okay, and then we're going to look at some specific points, 0, 0, negative 1, 1, 2, 2, and 3, 8, and try to determine where they are in reference to that decision boundary. And then in part D, we're going to do something a little bit different. We're going to explore what it means for something to be linear or nonlinear. So we'll get to that when we get to that. Okay, so parts A through C. So first we're just supposed to sketch this curve. I'm going to do all these together, by the way, A through C. We're going to sketch this curve, and then look at points, on either side of the decision boundary, and then look at specific points. Okay, so it turns out that this right here, this is just one way to write out the formula for a circle. So that has radius r squared, which would be 2 here. That's centered, at h and v according to this formula. Okay, which would be negative 1 and 2. Okay. So we will, all we're going to do is draw a circle. Okay, and there's a lot of ways that you can draw a circle. So you can look at the way that I've done it, or you can find your own way of doing it. But we're going to draw that circle, which I've done down here. We'll zoom in a second. And then I've added a set of grid points where, if we're on one side of the circle, we're blue. If we're on the inside of the circle, we're red. Okay? And then we look at specific points here, 0, 0, negative 1, 1, 2, 2, 3, 8. Okay? So just let me zoom in here. Okay? So you can see my circle, right? Centered at, I think, negative 1, 2. And so you see the decision boundary is the circle, and if we're on the outside, we're blue. If we're on the inside, we're red. Okay, and again, look at the code to see how that's done. And then we're looking at specific points here. And the only point that is inside of this decision boundary is right here, which is negative 1, 1. Okay. All right, so now finally, we want to argue that while the decision boundary is not linear in terms of x1 and x2, it is linear in terms of this full complement of this whole array of variables, x1, x1 squared, x2, x2 squared, where we're treating x1 squared and x2 squared not as the square of x1 and x2, but as their own individual variables here. And so the way that we can do this is just simply to expand our initial expression. And if you expand it, you get something that looks like either this or this. Okay? And this is a linear function, right? So we just have, so all of the variables are just being multiplied by the coefficient. Okay? And then each of these coefficient variable terms are being added or subtracted. And that's basically what a linear function is. Notice that it does not, linearity does not necessarily mean that if we were to plot it, it becomes a straight line. Okay, so the term linear is a little bit being used in more than one sense here. Okay, but yeah, I think that is good.